Hi, this is Yan. Welcome to Statistical Data Analysis, Chapter 1, Introduction to Statistics. We usually start our studies with a research question. For example, what is the prevalence of obesity in American school children? The way to answer it would be to interview all the 5 to 16-year-old children in the United States, which is the target population. It's the entire set of individuals or items of our research interest. And the features of the population are called parameters. In practice, it would be impossible to interview all the school children in the United States, so we take a sample to interview. We assume what is true of the sample will also be true of the target population. And the characteristics of the sample are called sample statistics. And the statistics are the mathematical procedures to summarize, analyze, and interpret the observations of the sample. As we said, we assume what is true of the sample will also be true of the target population. And the process to generalize from the population to the process to generalize from the sample to the population is called a statistical inferences. Examples of inferential tests are t-test, ANOVA, and a correlation, etc. And if we collect data on 100 American school children's weight and age, we'll have 200 numbers, which won't make any sense to us unless we organize and summarize them. We can calculate each age group's average or the percentage of obese children. The procedures to organize and summarize the data are called descriptive statistics. Clinical trial is an example of experimental design. For example, if you want to know if a new drug is effective in treating hypertension, here the presumed cause is the new drug, which is the independent variable. In the outcome variable, the dependent variable is the diastolic blood pressure. You select a sample and randomly assign them to two groups, the new drug experiment group and the placebo control group. Random assignment is to divide the sample in such a way that the two groups are as similar as possible. At the end of the trial, you compare the changes in average diastolic blood pressures and find out if the new drug is effective. Quasi-experimental design also compares the effects that the independent variable makes in the dependent variable. But in quasi-experimental design, the independent variable is usually a pre-existing condition, so there is no manipulation, no random assignment of the participants, so there is no control group. An example is comparing survival rates in patients undergoing different types of surgery, each performed by different surgeons. Well, different surgeons have different selection thresholds of risk for admitting patients, which may be the contributing factor to the survival rate rather than the surgical alternative. And the other examples are gender differences in aggressive behavior and age differences in reaction time. And the gender and age are both pre-existing conditions, which you cannot manipulate. In correlational design, we explore the associations between two variables. And a correlation coefficient is a statistic that summarizes the strength of the relationship. But this relationship is not necessarily a causal relationship. And the variables are measured as they naturally occur, so there is no manipulation, no randomization, or control. And the example is the strength of association between blood pressure and age. And from your data, you might see older people have higher blood pressure, but you cannot draw the conclusion that aging is the cause of high blood pressure. Another example is the SAT scores and college GPAs. Scales of a measurement. Nominal scales have no order and are categories with labels. The examples are gender, religion, place of birth, and you can assign numeric values to represent categories. For example, 1 is male and 2 is female, and 1 is married and 2 is divorced, 3 is single, etc. And values on ordinal scale have a logical relationship across the values, and there is some difference between categories, but it is usually impossible to measure the amount of difference. For example, subjects may be asked to rate their stress levels on a 5-point scale that ranges from no stress, mild stress, moderate stress, severe stress, and extreme stress. But you cannot say the difference between no stress and mild stress is the same as the difference between mild stress and moderate stress. So that's what we meant by you cannot measure the amount of difference between categories. Variables with numeric values that are measured by an interval or ratio scale are classified as scale variables. On an interval scale, one unit on the scale represents the same magnitude across the whole scale. And temperature is the best example here. Fahrenheit is an interval scale because the difference between 10 degrees and 20 degrees is the same as the difference between 40 degrees and 50 degrees. But there is no true zero. So 0 degree doesn't mean there is no temperature. Well, a ratio scale has the same properties as ordinal and interval scales, but it has a true zero point. And the examples are weight, height, or income, etc. Variables can be classified as continuous or discrete or categorical variables. And continuous variables are measured along a continuum, and they're measured at any place beyond the decimal point. And discrete or categorical variables are separate categories, and they can be whole numbers only. An example of a continuous variable is the length of a stay. And if you code it, it will be the number of days that the participants have stayed in the facility. But you can also turn this continuous variable into categorical or discrete variable by coding the days into 4 categories from 1 to 4, and 1 represents 1 to 10 days, and 2 means 11 to 20 days, and 3 means 21 to 30 days, and the 4 represents over 31 days. Binary variables are the categorical variables with only 2 outcomes. For example, yes or no, disease present or absent. And variables can also be classified as quantitative or qualitative variables. Thank you for listening. Please let me know your questions as soon as possible. And also, I'd like to hear from you how I can improve the presentations. Thanks.